If you've ever watched a briefing from NASA about an upcoming mission that it has, odds are at some point you would have heard something like this.
Liftoff of the Crew 11 mission is slated for Thursday, July 31st at 12:09 p.m. Eastern Time.
Targeted to lift off tomorrow, December 15th at 3:46 a.m. Pacific Time.
On February 6th at 1:33 and 32 seconds a.m. Eastern Time.
And of course, when it gets right down to it, the timing of the launch depends on a number of factors, on range readiness, on the weather that day, and other factors like if there's, say, a random boat in the keep-out zone at the wrong time. But when you're talking about missions that are months away or longer, like Artemis 2 for example, you might be wondering, well, how did they get that date, or why are they launching at that time? And to find that answer, we traveled to the Johnson Space Center in Houston, Texas. There, inside the White Flight Mission Control Room, we caught up with two folks at the helm of flight dynamics for Artemis 2, Natasha Peak and Mark McPherson.
So when we're setting a launch date, we're taking into account essentially a rendezvous problem with the moon. We need to end up where the moon is when we're going to be there and line things up perfectly so that we can use the moon's gravity to come back to the Earth, right where we need to get to our targeted landing site.
For those unfamiliar, the Artemis 2 mission doesn't actually see the Orion spacecraft go into orbit around the moon. Instead, once it performs what's called the translunar injection burn, or the TLI burn, about a day or so after launch, teams are also committing the crew to their landing timeline as well. So getting the timing right on a launch like this is even more critical. McPherson says part of how they do that is by considering something called the Earth-Moon antipode.
You draw a line between the center of the Earth and the center of the moon. Where that point comes out on the backside of the Earth is called the antipode. That sets up where our TLI burn is executed, such that we can go around the moon and come back. We also use that same antipode to determine where we're going to land. That determines what we call our entry interface point, where we first hit the atmosphere. As we move through the launch period, through the month, the location of the moon changes with respect to the Earth and with respect to the ecliptic. And so we have this geometry problem that means the location of entry interface moves from the northern hemisphere to the southern hemisphere. As that shift happens, we get farther away and then closer back to our target landing site in San Diego. So that's one of the considerations that we have to take into account when we're looking at launch opportunities.
Another key factor that Peak and McPherson have to consider is how much power the spacecraft can generate, in this case, Orion, and where exactly that power comes from.
We look at how much energy our launch vehicle and Orion can put into the trajectory, and we run a whole suite of analysis to see when we're able to reach the moon and complete that trajectory within the propellant that we have available. It ends up being not a full month, we're kind of talking lunar months here, because there's variation in how far away the moon is, where it is relative to the Earth in terms of declination, and what Orion is able to achieve.
Peak says a launch window can sometimes be planned years in advance. Look at NASA's Dragonfly mission, for example. When NASA announced back in November 2024 that SpaceX's Falcon Heavy rocket would launch the rotorcraft lander to Saturn's moon Titan, it also announced a launch period from July 5th through the 28th of 2028. Peak says they typically do about a year's worth of modeling at a time. When we spoke in September, she described where they were at that point in the timeline for Artemis 2.
So we're actually about to start our launch period 17, so that's February of 2026, final trajectory production work, where we do the highest fidelity modeling that we can of that launch period and really make sure that we have those trajectories the way that we want. The other thing that goes into it is, first there's the performance, there's, can you get there and back? And then there's, should you get there and back on that day? And there are other vehicle constraints and system constraints that go into it. For example, Orion is powered by the sun. It has solar arrays. And so we look at the trajectories in advance and screen them for eclipses that are so long that Orion won't be able to maintain its power. And those days, if you have an eclipse that's too long, we rule them out. We wouldn't launch on those days.
If you're watching this video on or about the time that we published it, we're less than 2 months away from the earliest opportunity that NASA can launch the Artemis 2 mission. And if the early February 2026 window does in fact hold, that means right about now, NASA is at a key decision-making point.
There are kind of a couple of points as we get towards launch at which we do that assessment. The final analysis that I'm talking about happens about 3.5 months before launch. We'll have a good answer. About 2 months before launch, we do a big presentation for the decision makers and the Artemis mission management team on the nuances of each of the launch dates to help them choose which ones we really want to target as our primary and backup dates. But we are doing things like talking to the comm networks and reserving dates as much as 18 months in advance.
With Artemis 2 just around the corner, there's a lot to talk about with this mission, from the crew that's launching, to the type of training that they've gone through, to what exactly they'll be doing throughout this roughly 10-day excursion. And so if you haven't already, you want to be sure to click that subscribe button down below and turn on notifications, because we have a lot of videos like this coming your way to make sure that you have as much information as possible leading up to launch all the way to splashdown. Reporting for Spaceflight Now, I'm Will Robinson Smith. See you next time.